I've started recording. Suad, you're on mute.
I said, tell me when I should begin.
Please proceed, Suad.
Okay, so let's begin then. So hello everyone, welcome to this second webinar of the LFI in data. So our second webinar within the Trusted AI principle will be around practical example. So just a few information before we dig in directly in the agenda. I'm Suad Wali from Orange. I will present and lead this webinar with Suzanne Malaika from IBM. Hello, Suzanne.
Hello, hello.
Hello. So the agenda, as you can see, is organized around, let's say, two parts. After a quick introduction around repeats, the 8 principles of our working group, you will have 20 minutes of presentation about practical example in the context of the repeats principle. And the second part is a round table about applying principles in a corporation for another 20 minutes. In the first part of the practical example, you will have two presentations. Classification of encrypted traffic application. Rosary NLG framework will be the second presentation. So I will tell you more after, but just before we dig on directly in the presentation, I will just remind the principles with repeats. So if you can go on the next slide, just as a quick reminder, we had a first webinar around the 8 LFAI principle for a trusted AI. You can, of course, go directly to the link that was appearing in your screen previously to consult any document, material, and the record that was already done about this webinar. But just a quick reminder, we decided within our working group for 8 principles that we think are of equal importance and value. No principle is of higher priority than another, and of course the principles are related to each other. So the 8 principles, let's say we have an acronym for this 8 principles, which is repeats. So repeats is for reproducibility, robustness, equitability, privacy, explainability, accountability, transparency, and security. So maybe Suzanne, you can go on the next slide, please. So first, and you will see 2 presentations today. You will have the classification of encrypted traffic application. So a presentation that will be made by one of my colleagues from Orange and 2 people from the University of Waterloo in Canada. And then after that, you will have natural language generation for AI decision explanation. Next slide, please, Suzanne. So just let me introduce a little bit the people who are going to introduce this presentation. So for the practical example, the classification of encrypted traffic application will be presented by Iman Akbar Azirani, Noura Liman, and Bertrand Mathieu. Hello, Iman, Noura, and Bertrand, and welcome to this webinar. And the second presentation about natural language generation for AI decision explanation. So this is the Rosea NLG framework, which is an LFAI project, will be presented by Ludan Stockley. So welcome, Ludan. Ludan is the CTO of Data and AI Lab at BNP Paribas. But first is the classification of encrypted traffic application. So let me welcome Iman, Noura, and Bertrand. Iman is working at the University of Waterloo. He's a researcher, and his research today revolves mostly around the intersection of AI, cybersecurity, and network management, with a focus on automation and scalability. Noura Liman is also from the University of Waterloo in Canada. So she's an active researcher and contributor in the area of network and service management. So today, her current research interest is in applying machine learning to networking and network management problems, including network security and traffic classification. And the third one is Bertrand Mathieu from Orange Labs in France. So Bertrand joined Orange Labs in 1994. He is a senior researcher whose main research topic are programmable networks, quality of service, transport protocols, and is currently using artificial intelligence to provide solutions for network classification and troubleshooting of encrypted protocols. So Iman, Noura, Bertrand, the floor is yours. You have 10 minutes for the classification of encrypted traffic.
Okay, thanks, Swad, for the introductions. And the last one will be the first one to start the presentation. So I'm Bertrand Mathieu with Orange Labs in Lannion, as you said. Noura and Iman will take the floor later in this presentation. So the topic of this talk today is about classification of encrypted traffic. So I will introduce the context of this study. So we can see now that the network traffic is increasingly encrypted. So you all know the TLS protocol for securing end-to-end communications, but now it goes even further with the new protocol like QUIC, first initiated by Google. Indeed, now not only the data payload are encrypted, but also the headers of the protocol are encrypted. And what we can see today is that almost 85% of the internet traffic is encrypted. And for Google's services, it's almost 100%, since they mainly use the QUIC protocol to deliver their contents. As a consequence of this encryption, there are less clear information inside the packet header. So now it's more and more difficult to be able to classify traffic just looking for keyword or for specific indication in the packets or in the packet headers. So there are still some few header fields that are unclear, but for how long, we don't know. We can say that the previous and still current solutions like the packet inspections are now very limited because of these encryptions. There are no means to detect and to classify traffic. So we need a new solution. And why we need one? Typically for a network operator, it is very important to have a knowledge of the use of its networks, and typically what are the main services and the main applications that are used by their consumer, and to which amount, which data volume for each applications. So why do we need it? We need it to anticipate the network evolutions, to prepare the capacity planning of our network, and also we can improve the interconnections toward internet actors. Typically, some years ago, when Netflix emerged, we have seen a lot of increase of Netflix traffic inside our networks, and then we increase our capacities, our links to Netflix. The idea, of course, is to offer the best quality to our customers. So for it, having this knowledge helps us to specify and to prepare different marketing offers. It also, this detection of traffic also allows us to prevent from the zero rating frauds. So zero rating frauds are typically frauds where one end user send data using another application behavior or application concern. So typically, if one network operator has a specific contract where each data has to be paid, except for all Facebook data, which is free for end users. So with zero rating frauds, people will try to send a video or other type of traffic, making it as if it looks like Facebook traffic. So via our solution, we are able to detect it and can prevent this kind of frauds. So obviously, all what we need is for our customers' satisfaction, which is driving us. So on the next slide, we will detail a bit more what we do with the data. So, and more specifically, having in mind the principles defined by the Trusted IA group and the repeats concept as Suad presented. So in our study, we mainly focus on three of them: the equitability, privacy, and explainability. So equitability, because our solution is equitable to any end users. Privacy, because it's the main concern and we should ensure the privacy on end user, so we never know what one end user is doing on the internet. And explainability, we should be able to explain what we do with the data and how. And that's exactly what these pictures above presents. So what do we do typically with the data? First, we have to collect the network traces from our networks. So we get this huge amount of data. First, we remove all the flows that are not useful for our classifications. We just keep what we need. Then we truncate the data payload. Of course, since now almost everything is encrypted, the data payload is useless, so we truncate it. In order not to be able to identify or to correlate one end user was doing this thing at a given time, we remove all temporal informations from the traces and set the first packet to the Unix epoch time. So 1st January of 70. So we have no more any time information in our analysis. And finally, we remove all end users and servers network related information. So it means that we remove the IP addresses of the endpoints. We remove all information about the security certificates. We removed all information in the protocol header that could help to identify one endpoint. So typically the SNI, which is the server name indication, indicating the name of the web server, it is also removed. And finally, we should mention that our classification is done on a global level and not per user. So typically, we'll be able to know that in our Orange network, we have, let's say, 45% of Netflix traffic, but it's in its globality. It's not that one user is having 45% of Netflix. So it's the globality. So doing like this, we are able to ensure the three repeat principles we have identified in the picture on the top. So I won't go into the detail of this figure, but you can see it. So now I will leave the floor to Nora to go into the details of the solutions.
Thank you, Bertrand. Hello, everyone. So as Bertrand explained, our starting point is this anonymized data that we received from Bertrand. This is basically encrypted web traffic. So we have packets pertaining to web protocols, so HTTPS, HTTP2, and QUIC. And from there, we try to classify this traffic as per service level or per application level. Okay, so we decide whether this flow is an online gaming flow or a web flow or a download or so on and so forth. We will see some of the classes in the next slide. So let's now focus on our solution. So first of all, our first step was to engineer the features, to decide what features are important to classify this traffic using an AI, basically a deep neural network solution. All right. So after long studies, we realized that it was important to mix different types of features. Of course, we got inspired by works in natural language processing and some other works, previous work in encrypted traffic classification. So we realized that three features were of paramount importance in encrypted traffic classification. We have basically raw bytes coming from the TLS handshake. And then we have the traffic shape, which is basically by looking at the flow as a series of packets, we can think of features pertaining to the size of the packets, the time series of the size of the packet, the direction of the packet, but also the inter-arrival time. So those define the shape of the traffic. And then third, we have those statistical features that are useful, but they are also very well documented, and they are provided by usual flow measures. All right, so quick recap. So we have raw bytes from the TLS handshake, we have the traffic shape, and we have also traffic statistics, flow statistics from flow measures. And so after doing this extraction, these features, which is in the pre-processing level of our work, we came up with this architecture, a neural network architecture that mixes CNN, so a convolutional neural network, and LSTM for a long short-term memory network layers, and then we have dense layers. So since we have three types of features, we will have three layers, so three series of layers working in parallel. And then, of course, this layer will be merged by dense layer to provide the classes or the labels at the end. All right, so we would, as you see in the picture, we will feed the first layers of the CNN with the TLS handshake bytes, and the flow time series will be fed to the LSTM layers, and then we have the standard flow statistic will be fed to the dense layer. Now, something that is very, very important here is that when we feed the TLS handshake raw bytes to the CNN, we remove those features or those headers that we call canary features. So these headers that basically give away the label at the end. And that's basically include the server name identifier, so CNI field, so we remove that one. And we also remove the TLS cipher, and we consider the other basically 600 first bytes of the TLS handshake. So of course, the CNI, we would have used it for labeling eventually some of the flows in our data set to provide us a ground truth on basis of which we will be calculating the accuracy of our model. All right, so the last layer, we, as I said, will identify the label of the class of the traffic at the service level, whether, for example, the traffic is a video streaming flows are video streaming flows or social networking or web, so forth, or if it's an application, Netflix, YouTube, Facebook, Gmail, so on and so forth. Next slide, please. So with our unique feature engineering in our model, three-faceted model, we were able to classify flows collected from the Orange mobile network after, of course, being anonymized as explained by Bertrand. we were able, thanks again to our features and our architecture and our trained model, to reach about 95% accuracy on HTTPS traffic. So you can see here in the picture, so for the leftmost, you see here a classification at the service level, and you see that the accuracy is quite stable across all the classes. Okay, we are around 95%. We were able to classify these flows at the accuracy of around 95%. We see on the right side, so the rightmost picture, you see also that the accuracy is very high, ranging between 95 and 100% over the different applications. So these labels are basically define the application level class of the traffic. Now, which is also great about this model is that it uses protocol agnostic features, which can basically generalize to different protocols, HTTPS, HTTP2, but also QUIC. And they can be also used for different classification objective. Here we saw service level classification, application level classification. Of course, these labels, whatever they are, the service labels or application level labels, they can change. Now, depending on the type of traffic you have on your network, you might basically train your model on different labels at different granularity. Next slide, please. Bertrand, you want to take over?
Yes, thanks. So this slide is not about a simple conclusion, as it could be, but more about what we think or what we would need and what we can request to your group or to LFAEA, or I don't know which one. But typically, as you have seen, we have anonymized all the network traces, but currently it is manually done via scripts. So it will be very helpful to have a generic AI tool that could offer such a function. So it will be, of course, interesting for us, but I think for many other people dealing with network packets. Second point is that since we are a network operator, we want to deploy this kind of model inside our network. So we should be able to have AI model very efficient, running at the network wire speed, so at very high speed. So now AI tools, AI models are running in dedicated computers. If it could be inside network, it will be very helpful for us. We also need tools to better explain the biases we can have with the model. Also to help to explain some decisions taken by the models and why this decision has been decided. And finally, of course, as for many services, it will be very good to have a tool that can prevent attacks to the models and make sure that it is safe. So that's more or less our request, I would say, or at least some guidance for possible work. So typically, we can imagine to have those kind of tools offer as a feature in the feature store, typically, or maybe somewhere else, I don't know. So that's all. So if you have any questions to Noura or I, will be happy to answer.
So any question or comments? If you don't think about questions and comments now, you can of course post them in the chat and we will answer.
Sure.
So just a few minutes. Any question?
Yes, François speaking. Thank you for the presentation, and a question to presenters. To what extent this the approach you have used could be reused in other contexts? Meaning, here it's about network packets, but is your approach applicable to other contexts? So in a few words, because probably you can elaborate a lot.
Maybe I will let Noah answer, since she already spoken about protocol agnostics. So maybe we can imagine to use it for other use cases. But Noah, if you want to complete.
So François, just to make, okay, so here we are moving from the network to another context. So it's not network anymore. All right, so so we're not talking about network traces anymore here. All right, so I mean, clearly, and Iman can confirm that, we were also motivated, and we were also inspired by works that were done in natural language processing. So these tensor layers, CNN, LSTM, they were used in other approaches in other areas. So definitely, I mean, what we learned here from our work is that we cannot stop ourselves or restrict ourselves to one type of feature just because it was proven to be working. Combining different features, as we saw here, row by statistics and traffic shape, boosted the accuracy of the model significantly. So I think our approach can be applied to other areas with this in mind, is that we shouldn't stop to what has been done, but eventually try to open up to different set of features and combine them, because mixing them together can make us reach a higher level of accuracy.
And if I may add something here, for a long time, the literature in this area has tried to establish some sort of analogy between network packets and computer vision, essentially trying to find, for example, a picture of Instagram, a picture of Netflix in the packets. However, the insight behind this particular approach is that encryption kind of changes all the rules. So essentially, unlike
Iman is
like
frozen.
a picture that
you were frozen for a little bit, but move on.
It's
you were saying that encryption changed everything, so you can move on from that part.
Yeah, so an encrypted packet is not like a picture. It's like a picture where 90% of it is obfuscated, and that is the primary insight that drives this particular feature engineering method.
Okay, thank you, Bertrand. Thank you, Nora, and thank you, Iman, for this presentation.
And if you have any questions later on, feel free to send us an email, or if someone listen to the recordings later, we'll be happy to reply. Thanks.
Yeah, of course, you can of course post comments on the chat, and you can of course ask your question on the Slack channel and on the Linux Foundation, the link that is provided there in the chat and at the beginning of the presentation. So of course, feel free to post comments or any question, and we will of course answer. Even if it's during the session, you think about a question, do not hesitate. Thanks a lot, Bertrand, Nora, Iman. Now it's time to go to the second presentation, which is about natural language generation for AI, decision explanation. So let me welcome Ludan Stockley. So Ludan is a professional of the AI software industry. Today is the CTO of the AI lab at BNP Paribas CIB, and is developing and industrializing AI products internally. So Ludan, welcome. The floor is yours.
Thanks, Aswad. Just tell me if the screen gets frozen or if myself I get freezed. So today we'll talk about natural language generation for AI decision explanation. So what is it about? The question is how to explain a decision to a non-expert end user. Today we will try to tackle let's say 2.5 of the 8 LF AI and data principles for trusted AI, and we'll talk about explainability and transparency, because a good and explainable decision leads to explainability and transparency. So we'll talk about trusting a decision, a single decision, not about trusting a model, which is something else. And a good explanation must have two characteristics. It must be first understandable for its target population, and this is important. And second, it must be automated to be scalable. So let's talk about some biases that we, as corporate users and data scientists, we might have. We data scientists, we love data more than everything, tables, and dashboard. And our corporate environments, they favor data and complex dashboards. And it's not such a bad thing, because corporate power users, they have the expertise and they can understand those dashboards. The issue is that corporate users and data scientists, we tend to believe that data and dashboards are a good way to convey information. But is it true? So let's take one simple example. So it's a numeracy test from OECD. So I can let you read the question. So the following graph shows the number of births in the United States every 10 years. And we are asked during which periods was there a decline. So there is no trick here. It's just a simple question. And I would say for most of us, the answer should be pretty straightforward. But welcome to the real world. In fact, such very simple line graphs, they are not understood by the general population. Non-experts, they will not understand statistics or data visualization. In fact, there are studies that show that about 25% of adults, they cannot compare information presented in a simple table. And what I say is that excluding large parts of the population of understandable explanation, this is not acceptable. We cannot accept it. Here I talk about non-expert users. We must be aware that it's not a homogeneous category. General population, non-expert users, it's not one single category. So one important question that we have to ask us is, who is your audience? What are their skills? And what is their level of expertise? What can they understand? And in practice, non-expert users, they tend to prefer textual explanation. So let's take an example. So it's taken from AI Explainability 360. So it's an example of a bank customer that wants to understand why his or her application was rejected and what he or she can do to increase the likelihood of the application to be accepted in the future. So here, I put two examples of explanation. So each time the credit application has been denied. For the first one, there is one main reason. If we read the explanation, it's pretty readable. The main explanation is your debt, which is high, but when your credit card, when your car credit will be fully repaid, your application will probably be accepted. So it's quite a simple situation and a simple explanation, simple and clear explanation. The second situation is a little more complex. So credit application has been denied as well, but this is due to a couple of reasons. Even if your existing debt is rather low, some of your internet bills were not paid on time. Also, you have moved twice during the last 3 years. And at last, you tend to use a large part of your available credit. So here, 3 reasons that explain why the credit application was rejected. Then if you continue pay your bills on time, like you did this year, if you stop moving and if you reduce the use part of your available credit, your application is likely to be accepted early next year. And you also give a hint at the end. Also, if you already used your missed payments, your credit charges will also be lower. So here we can see that language can communicate background, context, caveats, and give some advice. How can we do that? So producing such text, it's impossible to do manually at scale. It's too expensive. And it's also impossible to do it in real time. People, they want to have explanation in real time. They don't want to wait days before having an explanation. So if we want to do that at scale, we can use natural language generation. So natural language generation will transform data into text using textual templates. And it's typically used widely in production, typically in the financial industry. One thing that is not obvious is that, in fact, computer-generated texts, they tend to be superior from the reader's perspective to human-written text. The readers, they like computer-generated text because generally they are more clear, more straightforward than human-written text. What does an explainability pipeline using NLG looks like? So there are 3 steps in that pipeline. The first step is to actually interpret the decision. So if you use machine learning, you have to use an explainability framework like AI Explainability 360, Shape, Lime, or things you might already know. You can also, if you are not using machine learning but other artificial intelligence components, there are other ways to interpret the decision. So this is the first step you have to do. The second step is to define what you want to say. So typically, based on the data, which is the output of the interpretation, what do you want to present to the user? So it's typically about finding the key insights, present them as a story, and being sensitive to user goals and knowledge. You don't have to say everything. It has to be clear and to tell a story. So typically, this is done by filtering the data, by applying static rules, simple statistics. So it's not technically rocket science, but you have to write some code to do that, typically using Python or anything. And third and last step is how to say it, which is actually producing the text, telling the story. So to do that, you can use a textual templates and a natural language generation engine. Rosai NLG is one of them. Present it just on the next slide. A few good practices. So at design time, you have to define what is a clear explanation for your user and your use case. It's very important to be sensitive to user goals and knowledge. It's also important once in production to ask your user for feedback. Was the explanation clear? You have tried to provide a clear explanation, but is it clear in reality? And you might also have to adapt to your real audience at runtime. You have made some assumptions about who your audience will be. Maybe you're not exactly like what you had imagined. Last slide is about Rosai NLG. So Rosai NLG is one way to implement the third step of that pipeline. So it's a natural language generation engine. It's open source under Apache 2.0 license. It's designed to be developer and IT friendly. It supports multiple output languages with embedded linguistic resources. Today we have English, French, German, Italian, and Spanish. We have quite an extensive, so it's both expensive to maintain, but it's extensive as users, documentation available. And you have an awesome logo that you can see, and yeah, it's a LF AI and Data Sandbox project, and actually it's the first sandbox stage project of the LF AI and Data Foundation. I think that's all for this part of the presentation. Do you have questions or things you want to react on?
Yeah, thank you, Ludan. Any question, any comments on this presentation?
Yes, François, thank you, Ludan, for this very clear and interesting presentation. A question related to, I would say, the level of confidence you can get from this system and the solution you have developed along the time. So you enter in an interaction loop with the users, but is the system able to improve its behavior by itself, or I mean by using some algorithms or tricks that could help to increase this level of confidence?
That's a good question. Actually, in this pipeline here, there's no self-learning. I mean, when you say, when you give feedback and you say the explanation was not clear, it does nothing. It doesn't retrain the model. There's actually no model behind the Rosa NLG. You just get the information that this sample explanation was not clear for this specific user. So after that, you have to figure out what was not clear and to improve typically the templates, or the second step, which is what to say. Maybe you didn't give the proper explanation. So there's no self-learning loop involved here. If you want to improve the generated text, the explanation, you have to change the templates, the third part, and the second part, which is what you actually say to the user.
Okay, thank you. You have a question from Jim. Maybe Jim, you can ask your question directly.
Maybe he can't unmute. It says, would you? Oh, go ahead. Go ahead.
Can you hear me now? Can you hear me?
Yeah, we can hear you now. No worries, no worries.
Yeah, I was wondering, both use cases, by the way, the previous one on encrypted network traffic and this one on natural language generation for explanation are very interesting and intriguing. So thank you. I'm just wondering if we'll start with the NLG explanation one. Are there data sets, open data sets available for this use case that you know of, Ludwig?
So there are actually open data set for natural language in general. I think one of the most famous one is about generating text for I think it's for basketball matches, but you don't have an open data set about AI explanation. I'm not aware of any data set in this specific field. And most of the time, the data set, they concentrate on the how to say part, which is actually not the most difficult part, but they don't focus on what to say. And I think the concern about natural language generation, we focus more and more on about what to say based on a data set than exactly how to say it.
Mm.
And for the first use case, maybe I can reply. Unfortunately, our data set won't be public. We can't make it open because it's principally our business. So we can't make it open because of many issues. And I was in contact with some researchers from Huawei, and they also capture network traces in China, and the same, they don't open their data sets. So I'm afraid for the network traces, it might be difficult to get some.
Yeah, I'm thinking to make good progress. Thank you, by the way, for both of those answers. I think to make good progress in the future, it probably might be good to try to think about open data sets for these, because it would invite more people to get active in these research areas. And I think the network traffic one might be set up synthetic data. There might be a way to set up some synthetic data. I'm assuming in the explanation.
I'd like to, I'm sorry to cut off the discussion, but we do need to move to the round table.
Yeah, I was about to say the same.
Yeah, so to be fair on our roundtable attendees, is that okay, Bertrand, Jim?
Yes.
Yes, sure. Go on.
Okay.
Anyway, you can discuss later on the chat, or
yeah,
even,
we'll leave it open, but we do have some people who need to we do need to move on to the round. Is that okay?
Yes, it's okay, no worries. So it's time for the roundtable. So Susan Malekas from IBM, she will present the roundtable.
Yes. So I'm Susan Malika at IBM, and I'm going to talk with our great roundtable folks, Calvin Lawrence, Alejandro Cesedo, and Emily Servahin from France and from Orange. So what I'm going to do, rather than do the introductions, I'm just going to ask the first question to the roundtable, and as each person answers, maybe they can introduce themselves first. So the first question is, what is your feedback on the practical examples? So Calvin, Alejandro, Emily, who wants to go first? Anyone want to go first?
I can jump in.
Okay, and please introduce yourself as well, Alejandro, first, and please respond. Yeah.
Sure. Very briefly, my name is Alejandro, Chief Scientist at the Institute for Ethical AI and Engineering Director at Selden. So just some general thoughts. I want to say more than anything that this is, fantastic. It's really exciting to see how there is some explicit efforts to try to understand how this very tactical, low-level, practitioner-focused tools can map into such a high-level set of principles. And I think this is really the challenge that as organizations and as practitioners, we will see facing day to day, understanding how those northern stars that would constitute of principles can then be carried out in a more practical manner. So my main thoughts is just wanting to see more of this and continuing this as a further sort of momentum, seeing how this can perhaps even extend into not just the features themselves, but the governance process, as well as perhaps even on the operational use. So in the case of ROSA-NLG, there would be some domain experts that would be doing some explanations on top of particular use cases to understand what output of the machine learning is trying to say, understanding how to introduce those principles to ensure that the operationalization also follows that. So yeah, that's kind of like some high-level thoughts, and I'll just pause there because I'd love to hear also Calvin's and Emily's thoughts.
Yeah, well, I mean, I thought also that both examples were quite applicable to the subject matter, although they're quite different. I'll introduce myself. Calvin Lawrence. I'm a distinguished engineer and CTO for our cognitive and AI solutions are in public sector. So public sector to IBM is federal government, state and local government, healthcare and life sciences, and education. So my job is not only to work with our clients in those spaces, but to ensure that our solutions inside of IBM, as well as our architectural principles that we kind of deploy as we work with them are both ethical and we can explain them to our clients. And that's a pretty tall task, especially over on the federal government and state and local government side. I really kind of got fixated out of the two examples really on the NLP and the explainability one, especially with the credit example. I thought that was interesting because just that's something that I'm closely affiliated with. That I've seen quite a few examples where folk like my mom who would get denied for credit, and it would be some AI app or some technological decision, and she would be, as a non-technical user, dumbfounded on why that decision was made. So with that said, I mean, I like the idea of really not only determining what to say, but how to say it. But, you know, my thought is not just to explain the decision away, because most of the time, the folk either know, kind of have a good idea of why that decision might have been made, but they don't know really how to mediate it or remediate that decision. So my recommendation is not only to explain the decision from an explainability perspective, but give an example of a successful conclusion. a recommendation of what it would look like to get approved, right, for that loan. Right? It could be not just giving me specific things that I need to consider, but AI basically being having the capabilities for machine learning, you should be able to give me some very specific things about my situation. So giving me examples and an action roadmap, in addition to this real-time feedback, I think is an area that I know at IBM that we're working on. I think the industry should spend some time on that also.
Thank you. Thank you, Calvin. Anyone else wants to remark on the comments from Alejandro and Calvin before we move on to the next question?
Emily, I can perhaps introduce myself and also react.
Please, Emily, introduce yourself. That would be great.
Yes. So, Emily, I'm at Orange, and I'm in a data and AI entity who drive Orange strategy on AI. And for my part, I focus on responsible and ethics AI. And I'm trying to implement concrete from principle to concrete implementation. And my comment on what we have just heard is about these things. In fact, the principles are really giving us an ambition and an aim, a global objective that we all want to achieve. But when we study specific use cases, we see that the principle have different meanings depending of the context of the specific usage, the specific impact of the system and the user or the people around the use case. And this is really this tricky part of implementation of the principles. Then there is the subject of which tool to use in this specific case to answer to these specific needs. But that was my comment on the we've seen different contexts and different use of AI and different meaning of, for example, if we take explanation for a network supervisor who wants to analyze the quality of service, it will not be the same the same needs and the same way of implementing explanation comparing to bank and user, credit user. So.
Thank you, Emily. Thank you, Calvin. Thank you, Alejandro. And some of you have alluded to aspects of the next question, which is how do you incorporate trusted AI principles into your project development lifecycle? Anyone want to go first or respond to that question?
Yeah, I'll jump in.
Okay.
I'm a firm believer that really AI and ethics need to be ingested into the DNA of what we do, right? For the full life cycle development process. So from the time that an idea is being vetted from a design thinking perspective all the way until that solution reaches the hand of the end user or the stakeholders, that we must be considerate during that whole process, that entire process, all the tentacles of that process. We need to be concerned because at any point, if the system breaks, right, if that solution gets touched, even at the design thinking, it can affect the entire solution. So, you know, to the question, I'm a firm believer that it needs to, that AI interest, AI concern, AI fairness, explainability, and all of those key areas that was kind of identified up front need to be considered during the life cycle of a development process.
Thank you, Calvin. Anyone else before we move on to the next question?
I can just completing what Calvin just said. We have to ask questions at each step of AI lifecycle from the very beginning, when we have the data and exploration of data, when we choose the model and the test, the evaluation of the model, and all along the life of the system, we need to monitor every time that the principles are still applicable. So it's really all along the life cycle that we have action, in fact, to apply those principles.
Okay, very good. Thank you, Emily. Anyone else?
Just a small comment on my part, Suzanne, but I think that Alejandro will certainly will be able to comment more about the definition of the principle. You know, Emily, just to answer your comment, the idea within the LFAI was to decide about common definitions so that when a data scientist or any people working on the machine learning side, they don't have to ask themselves, what are the definition of the principles we are talking about? So we decided it was a common work. I would say it's a very international work. So normally the definition we put should be usable in any LFAI project or any machine learning project, I think.
So
The idea is to
we
know
should
how.
let Alejandro respond because he's going to drop on the hour. And then we can carry on.
Sorry for that.
Whoever can stay on will stay and we'll finish up. Alejandro, do you want to make your final remarks before you have to leave us?
Absolutely. No, thank you so much, Sowell and Susan. No, I absolutely agree. And I think just to kind of like mention the tail of your point, Sowell, and also Calvin and Emily who have mentioned this, I completely agree that every single part of the design, development, and operation of AI systems from both the technical and non-technical stakeholders have to be done with these principles in mind, whether it's a trusted AI, the OEDC, or whatever principles are adopted, that there is a Northern Star that ensures the humane development and the trusted AI development. It is, from my perspective, one thing that I would kind of like reemphasize from SOADS is that it is very key to see that the trusted AI principles that are coming from the Linux Foundation have a very practitioner specific focus, which is great for people that are in the midst of this AI revolution, building these core components. And I think from that same perspective, this allows for a much more tactical conversation in how not only this can be achieved on the high level, but on the more practical underlying infrastructure. How do we make sure that this is not only put in place, but that the programmatic governance and compliance can be met? So I think that is absolutely important. And I completely agree with all of the points that have been made.
Thank you, Alejandro. I hope, I know you have to depart, but I hope Calvin and Emily can stay a few minutes longer. Can you, Calvin and Emily?
I can.
Okay,
yes.
Good. Okay. So we're going to change direction a little bit and talk about an ethics board. Do companies, large companies, need to have ethics boards, do you think? I don't know, Emily or Calvin, which of you would like to comment on that?
I can answer that what is needed is a governance, in fact, an organization to deal with those ethics topics. And one tool to manage this governance is often an ethics board to help the company to organize, and this ethics board should also be supported by the head of the company or the organization and have a strong leadership from the head. And then it's also a way, a tool to give the guidelines, the high level value of the organization and the priority that we should focus on. And then help all the projects of the company to deal with that, to give the direction.
Thank you, Emily. Any feedback from you, Calvin?
Yeah, I mean, I totally agree with Emily. I'm a strong believer that companies should really consider setting up a kind of a dedicated AI governance and advisory committee, really, and it needs to be sponsored, as Emily suggested, by the senior leaders, and it should include really all of the cross-functional leaders and external advisors, including the end users, right? Including examples from the end users of folk who are going to be affected. And I know that's sometimes difficult to do, but that the folk who are going to be impacted by bad decisions from your AI algorithm needs to have a seat at the table in some of those, or at least a feedback. It should be a feedback mechanism into that community.
Thank you, Calvin, for those very important remarks. And just to finish up, just to extend the discussion a little bit, should these boards or bodies have people from outside the organization, from other companies, from any comments on that?
I would love to see that, and I don't know how practical it is, because what's happening in the industry is that even though this topic is a very important one, we have a tendency of being very competitive, especially at our corporate level. So we compete with each other to have the best AI fairness framework, the best explainability framework, and others. But in the end, I think the goal is to basically not only provide oversight, but to remove all inhibitors for to all of the great capabilities and possibilities that AI provides. So to your question, I believe that we should not only have external users, I think that we should have a kind of a cross-industry perspective or view or board, and have folk from different companies like IBM. At IBM, we probably should have a view from Facebook, probably should have a view from Oracle, a view from Apple, right? And on their boards, it should be very similar, because it's not going to help us to basically to go off and build a lot of solutions that really compete with each other, when really we have a common kind of problem here that we're all trying to get ahead of.
Thank you, Calvin. Emily, you were going to interject as well. Please go ahead.
Yes, I wanted to say that it's not an obligation to have external people. It's both ethical principle and values is first an organization topic, and it's important to have different representatives from the company to exchange on the risk and the problem and the decision that has to be made. But having external experts help to open mind and to have other advice and other ideas of what we can choose to do. So, for example, at Orange, we plan to have both internal ethics board for each country or subsidiaries we have, and then we have one group ethic board with external experts to have this both work.
Interesting. So you have a federated or a distributed model for your board or for your board operations. Interesting. Yeah. Yes. So thank you, Emily and Calvin, and the departed Alejandro, and thank you to all the speakers. And before we finish up, I wanted to just point out we do have our next session scheduled for September the 15th, where we're going to actually start looking at tools and discussing the tools to be applied in these contexts. But I'd like to ask Suad and anyone else if you have any final remarks or comments.
No, just a huge thank you to all the people who presented, also to all the people who were present during this roundtable. And of course, everything is a teamwork, so feel free to join our initiative to help us, and we will help you as well. Thank you very much to all of you, and have a nice day or evening, depending on your time.
Thank you, team. Enjoyed it.
Thank you, everyone. And also a last call. I'm going to prepare a blog for this session. So if anyone wants to help with that, that would be awesome, to capture some of the points succinctly so that people can just pick them up from the blog rather than listening to the whole session. And thank you, Suad, so much for everything you do for this working group. So
thank you as well, because you're doing a lot as well. I can help review the blog if you need.
Thank you, Suad. Thank you, Francois. Thank you, all the speakers, Iman, Noura, Bertrand, Luda, Calvin, the departed Alejandro, and Emily and Francois. Thank you.
Thanks. Have a nice day. Bye-bye.
Thank you.
Bye-bye.
Okay, thank you. Bye-bye.
Bye.